Skill Practice 4 asks us to repeat example 4, where we're decomposing a vector into orthogonal vectors, but we're doing it with different values for vector v and vector w. We're going to be using the values of vector v equals 7, -3, and vector w equals -2, -6. When we decompose vectors into orthogonal vectors, we need to find vector v1 and vector v2, which sum to the overall vector v. Vector v1 is equal to the projection of vector v onto vector w and is found by taking the dot product of vector v times vector w divided by the magnitude of vector w squared times vector w. Since vector v is equal to the sum of vector v1 plus vector v2, we can solve for vector v2, and we get that vector v2 is equal to vector v minus vector v1. We first start part A by finding vector v1, which we need to calculate the dot product of vector v times vector w. That's equal to the product of the A components plus the product of the B components. The dot product of vector v times vector w is then equal to 7 times -2 plus -3 times -6. We then have -14 plus 18, which is 4. Now we calculate the magnitude of vector w, which is found by taking the square root of a squared plus b squared. That's equal to the square root of -2 squared plus -6 squared, which is equal to the square root of 4 plus 36, which is equal to the square root of 40. Plugging these values into the formula for vector v1, we get 4 divided by the square root of 40 squared times vector w, which is -2, -6 in component form. Simplifying, the square root of 40 squared is 40, so we have 4 over 40, which we can reduce, times -2, -6. 4 over 40, if we divide out a 4, we get 1 over 10. And now we're multiplying the vector times a scalar. We have 1/10 times -2 and 1/10 times -6, which we can reduce because they're all even numbers. Dividing out a 2 from 2 and 10 and 6 and 10, we get 2 divides into 2 once, 2 divides into 10 5 times, 2 divides into 6 3 times, 2 divides into 10 5 times. We then have 1 times -1 over 5 times 1, and 1 times -3 over 5 times 1, which gives us -1/5, -3/5. For part B, all we have to do is take vector v minus vector v1, and we know that vector v1 is equal to -1 over 5, -3 over 5. Vector v was given as 7, -3. In order to find vector v2, we take vector v minus vector v1, but vector v1 is a fraction, so we need to find a common denominator between vector v and vector v1. So I'm going to multiply vector v times 5 over 5, both the a and the b component, so that I can then do the subtraction that I need to do. We then have 35 over 5 and negative 15 over 5 minus negative 1/5, negative 3/5. Vector v2 is then equal to 35 minus negative 1/5 and negative 15/5 minus negative 3/5. Minus a minus becomes a plus. So that's going to be 35/5 plus 1/5 and negative 15/5 plus 3/5. Vector v2 is then equal to 36/5, negative 12/5 in component form.